All right. Is this working for everyone? Can everyone see my screen? All right. Sounds good. So yeah, since it's pretty much 3:03, or at least 3:03 in Central Time right now, we might as well get started. And I did see a few questions asking about whether we'd be using Java and how that would work, and I'll answer those in a second. But first, I'll just quickly introduce what sort of class this is, and also myself. So yeah, hi everyone, and welcome to the USACO Bronze coding class, where we will be learning about USACO and sort of just coding programming in general. As you can probably guess from the title, I will be your instructor, Rich, for the next 4 weeks, and we'll be going over a few competitive programming problems, and hopefully you guys are all able to learn quite a bit. So since you guys probably don't know who I am yet, I'll just quickly introduce myself as well. So some things I enjoy doing in my free time are playing the recorder, juggling, and of course, doing competitive programming. Some things that I am very proud of are that I can eat extremely quickly, and also that I think that, well, at least I believe that I'd like to believe I'm pretty good at programming, which is why I am teaching this class today. So hopefully that gives you just a bit of more insight into who I am. So since we've already delayed long enough, we might as well get started now. So before we begin, there are a few things I want to mention. And the first of which is that we will be using Java for this class. Now, I'm sure that there are some of you out there who are wondering like, oh, well, I don't have much experience coding with Java, so should I still take this class? And there are probably others of you out there wondering questions like, oh, well, I have experience coding with a language such as other coding languages, like C++, Python, C#, that sort of thing. But I don't have that much experience with Java. So should I still take this class? And the answer that I have to you is that I will be emphasizing USACO problem solving primarily during this class as compared to like specific Java implementations. So as a result, I still think that you still will be able to gain quite a bit from this class because you'll still be able to sort of learn about USACO problem solving techniques. And even if you're coding in a different language, the problem solving techniques that are used throughout USACO are still primarily the same, which is why I think you'll still be able to learn quite a bit. However, because I will be focusing on like typing in Java and things like that, learning Java syntax will still make the overall experience a lot easier and will allow you to learn the material a lot quicker if you are familiar with Java syntax. So because of that, I highly recommend you all to go to this link right here. And I just realized that none of you can access the link. So I do see a few of you asking about whether you will receive a copy of the handout. And yes, I completely forgot to add that. So let me quickly type in the link to the Google Classroom, and I'll quickly disable chat so no one can say anything. But the link to the Google Classroom with all of the handouts is now posted in the chat so that you all can join. I will also note that if you do not wish to join the Google Classroom, although again it's recommended, the links to all of the handouts for all of the classes were posted on the Kid Teach Kid website at some point. However, this page is still under development and it should be finished by around tonight. So don't worry if, for example, you don't have a Google account or you do not wish to join the Google Classroom, because everything will also be posted on the Kid Teach Kid website under the Resources tab. However, if you do join with the Google Classroom, you will receive a notification every time something new is posted, which is why it's recommended that you also do join the Google Classroom. All right, and I'm assuming that the link has been in the chat long enough. So now I will unmute the chat and you guys can all talk again. So yeah, and once again, if you do not have much experience with Java programming, I highly recommend that you go to this link right here. And this is just sort of a link to one of our old Java programming courses, which is by Dan. And he sort of goes over an introduction about all the Java syntax, such as for loops, while loops, if statements, and all that sort of thing. So if that's something that you want to learn before sort of going over the USACO Bronze class, then you can feel free to take those to like sort of go over the videos in your own time. Oh, and one more thing that I would like to mention is that, again, if you do not have Java or a Java IDE downloaded, then you can also follow the instructions from the handout here to do so as well. And this handout is also posted in the Google Classroom. You can find it here. It is called Handout 0, Java and Eclipse Installation. And this will just allow you to sort of have a Java editing software on your computer. So you don't have to like go online for Java editing software. You can just directly go onto the computer, stuff like that. So yeah. And for this first week of our Java class, we will be going over a Java syntax review. And what this basically means is that although I'm sure that there are a lot of you who are familiar with sort of everything about Java, their data structures, the data types, I'm sure that there are also some of you out there who are not as familiar or would need like sort of a quick refresher about what is used inside of Java so that we can sort of solve these problems. So as a result, I've decided that for the first week, we will quickly go over everything, all the commands, data types, data structures inside of Java, and how why they might be useful in USACO problems, so that everyone can sort of have a better understanding of how Java works. Although, once again, this is not really a great replacement for directly learning about like how to code in Java, and I still recommend that you go to this link in the handout in order to learn more about like just everything in general. And I think with that, that's the end of the introduction that I wanted to talk about. So does anyone have any questions that they would like to ask? Oh, and something else is that I do encourage all of you to use the Q&A feature in the Zoom webinar to ask questions, or else it might be a bit easy for your question to get lost in the chat. All right, it does not look like there are any current questions. So I suppose that we will move on to the first part. Oh, someone wants me to put the link in the handout again? Okay. Give me 1 second. I will put the link to the Google Classroom in the chat again. Okay, I just put the link in the handout. Sorry, I just put the link to the Google Classroom, which contains links to both of the handouts. So now, since there are no other questions, we will move on to the first part. So first, let's talk about data types. So what are data types? Well, data types in Java are just another name for variables, and they are used in competitive programming to store information. And you might be wondering, well, why would these be useful? Because can't the computer just store the information by itself? And actually, this is not true, because even if we give the computer numbers, it won't know what to do with them unless we like store these numbers in a variable and then use these variables to do something. So as the example that's given in the handout, if we give our computers the number 2, 3, and this really large random number so that it can average these numbers, our computer can't do anything on its own if we don't store these numbers and then do something with them ourselves. So that's what data types are used for, to sort of store information. So now let's start out by talking about the simplest type of data type, which are integers. And there are multiple types of data types, and the most useful ones for competitive programming are integers, decimals, Booleans, characters, and strings. And all of these are they all sort of have their own uses in the USACO Bronze programming classes, which is why we'll be quickly covering them all. So integers are exactly as they sound. If you're not familiar with the term integers, you can just think of them as numbers. For example, -1, 0, 1, 2, 3, 10,675. All of these would qualify as integers. And whenever we're storing integers in competitive programming, we will generally use the integer or the long data type. So a few features about integers. As expected, we can use all of our normal like computing operations on them. So this means that we can tell our computer to do 1 + 1. We can tell our computer to do 2 - 1, 2 × 2, 3 ÷ 4, and like 3 modulo 5. And all of these operations our computer will recognize, which is good. Something that does sometimes pop up as well is that we will need to take the power during one of our problems. For example, 2 to the power of 3 is equal to 8. But since there's not really a great symbol for this that Java uses, we will use the mat.pow function instead to represent this. Another note is that this is the Java programming language. This is not Python, this is Java. And if we divide two integers in Java, then something else to note is that the remainder gets thrown away. So for example, if we try to do the integer 3 divided by the integer 2, it will equal 1. And I mean, I'm sure that all of us know that this is not actually true because 3 divided by 2 obviously does not equal 1. But the thing is, because Java sees both 3 and 2 as integers, it will actually remove the remainder. So we know even though 3 over 2 in actuality equals 1.5, since 2 and 3 are both integers, then the decimal point at the end will just get removed. And obviously this is a problem because there are times when we want to keep the decimal points at the end. And if we do not want this to happen, then we will have to use a double data type, which we will describe in the next section. And some of you might also have noticed that I mentioned that we would generally use the integer or the long data type. And you might be wondering, well, why don't we just use one of them? Because isn't using one of them a lot simpler than having to use both? And the main reason we generally use both the integer and the long data type is that integers can only store numbers between -2 billion and 2 billion. Whereas, between -2 billion and 2 billion. Whereas longs can store much larger values. So for example, I believe the bound for longs is that they can store up to like 9 quintillion or something like that, something really big. So as a result, we generally prefer to use integers when we're working with small numbers, but we will use the long data type if we are working with larger numbers. And since that was a big wall of text, I think it might be easier to sort of see how this would be implemented in Java. So as you can see, the first 3 lines represent how we would declare a variable for integer or long. So we would first declare the data type, which is int, then write down the variable name, which in this case is x, and then set it equal to the value that we want it to be. So in the first case, when we type in int x equals 1, x would take on a value of 1. We can similarly type in int y equals 2, and then y would take on a value of 2. And lastly, if we typed in z equals 4, I believe this is 4,110,110,114, then this would work as well, and z would take on this ridiculously large number. Something to note here is that because this number right here is actually larger than 2 billion, we have to use a long in order to take the value. Because if we tried to use an integer, it would not work because this value is bigger than 2 billion, and integers can only have values up to 2 billion. And next, this line right here about x plus y plus z over 3 just sort of shows how we can use addition and division inside of Java. So for example, we can if we set a equal to x plus y plus z over 3, well, we can see that because x is 1, y is 2, z is this ridiculously large number, and when we divide it by 3, well, I mean, I don't have a calculator on me, but let's just say, but I did this in the past, and we know that this is the answer that a will end up equaling. So yeah. Addition and division pretty much work exactly the same. And again, here's an example of why when we do integer division, we have to be extremely careful. Because when we type in int b equals 1/2, like we all know this equals 0.5. But because both 1 and 2 are integers, the 0.5 at the end gets deleted. So 0.5 to Java is just 0. So b would take on a value of 0 in this circumstance. So we have to be careful when dividing integers. Oh, and something else I wanted to point out is that I'm not sure that all of you have seen this percentage sign before. And this percentage sign just means like the remainder when we divide. So in particular, if we set c equal to z mod y, we know that z is equal to 4. We see that z is equal to like 4 billion something 4, and y is equal to 2. When we divide z by y, or when we divide 4 billion something blah 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 4 by 2, we get a remainder of 0 because z is even. So as a result, c would have a value of 0 because the remainder is 0. And lastly, this is just the syntax for how one would use the power function. So int d equals math.pow y3, and this just means we let d be the value when we raise y to the 3rd power. So d would have a value of 2 to the 3 equals 8. Does anyone have any questions before we move on to the next section? All right, I see a question that says, why don't I just make everything a long? So this is actually something that people do. Like there are people in the competitive programming world who, because they want to sort of store every type of integer and avoid getting integer overflow, they will make everything a long. And although this is technically possible, I would encourage you to try to avoid that generally. Like in USACO Bronze, it doesn't matter too much, but as you get like further into competitive programming, there are times when since longs actually do take up more memory, there are times when using longs too many times will exceed the memory limit for the problem, and that'll give us the wrong answer because we've used too much memory. But although yes, longs in general are better than integers because they store more information. All right. Now, if there are no other questions, let's move on to the next section, which is how to use decimals in Java. So decimals are actually pretty similar to integers, except for the fact that they have a decimal point, basically. So whenever we want to store decimal values in Java, we're generally going to use the double data type. And again, all of the normal operators work. Addition, subtraction, division, multiplication, all of these work, but we can no longer use this remainder thing symbol. To take powers with doubles, which is something else that might pop up, we again use the math.pow function. And again, and luckily, since doubles are technically decimals, whenever we divide two numbers, the decimal point will actually stay here. So if we're dividing two numbers and we don't want the decimal part to go away, then we will use doubles. And examples in Java for all of this are here. So as you can see, if we want to declare a double called D1 with value 3, then we can do so. If we want to declare a double D2 with value 3.00, then we can do so. And something to note is that D1 and D2 take on the same amounts of, D1 and D2 take on the same amount, sorry, they're actually the same value, because even though this is 3.00 and this is 3, the 0.00 doesn't actually do anything, so these are the same value. We can also do, we can also do multiplication and division, so long high equals this value. It ends up equaling 45, but this is just to show that addition and division, all this stuff works. Now here we have double D3 equals 3 over 2. And in this case, D3 will actually equal 1.5 because, oh, actually, I just realized this is a small mistake, but I'll fix this later. Okay, it's fine. But the mistake is that even though we are declaring a double here, we're still dividing by two integers, so one of these will have to be 3.2. So just ignore this for now. I'll update this in a second. But in the next example, we have that double D4 is equal to 4.0 over 3. And the reason D4 equals 1.33, and we do not get rid of the part at the end of the decimal, is because 4.0 is a double. So when one of the things on the numerator or the denominator of a fraction is a double, then the fraction divides as normal. And of course, this is just another example of using math.pow. So we take math.pow and we want to take 2 to the power of y. Oh, wait, whoops. We want to take 2 to the power of y. And if we remember from before, y is 2. So 2, okay, wait, I messed this up too, but yeah, okay. Just know that math.pow works in general. I will update this as well. But yeah. Does anyone have any questions? All right, let's see. Why do people use double instead of float? One reason that people use double instead, actually, this is an interesting question. I remember in the past, I used to always use float because I thought it was better. And I don't actually know the exact answer to this question. I do know that people in general will use double in the competitive programming community. And I believe it is because double stores, because double does store like larger values than float. Like it can be more precise with its decimals. I believe double goes up to like 17 decimal places, whereas float is around 8. So as a result, people like to use double because decimal precision is generally more important. And yeah, it's mainly just because double can store more decimal place values. Can double store big numbers like longs? And the answer to that is yes. Doubles and longs are the two types of data types that can store extremely large numbers. Does anyone have any other questions? Oh, does a double take more data than a float? Yes, a double does take more data than a float. And you might ask, well, why why wouldn't we use floats when we want to save memory? I actually have no clue. I just know that it's customary to always use double. And yeah. Is there anything longer than a long? There is a method called big integer that you can use, but big integer is not part of the actual Java, like it's not part of the original Java programming language. So you have to import this. And also big integer, even though it does store much bigger than long, it's extremely difficult to use. And like for USACO, we won't have to ever store any numbers that are longer than the long. So we generally don't talk about these. Well, like we generally won't use this sort of stuff. And what characters are used to write the OR function? Wait, the OR function? I'm not sure if you're talking about something. Okay, if you're talking about in conditional statements, it is this. I just sent the answer in the chat. But yeah, we will talk about conditionals later if I am thinking about what you if I'm correct about what you're referring to. All right. So the next data type we'll talk about is Booleans. So Booleans are pretty simple because they can only take on two values. They can only either be true or they can be false. So for example, if we set the Boolean high equal to 1 plus 1 equals 2, then high would equal true because, as we all hopefully know, 1 plus 1 does actually equal 2. And yeah, Booleans are overall pretty simple. They just sort of represent if a statement is true or false. Something else that is worth mentioning is that the operators and or, which is what I believe the question in the chat was about. These are the symbols that are used to sort of combine two Booleans into one Boolean. So and only returns true if the two Booleans it combines are both true, whereas or only returns true if at least one of the Booleans it combines is true. And if you've never seen like this symbol or this symbol before, it may be a bit confusing. So I've provided a few examples below to hopefully make it a bit easier to understand. So as you can see, we can declare a Boolean to be true. Here we declare a Boolean to be false. Here, Boolean B3 is true because 1 plus 2 does actually equal 3. And here, Boolean B4 is false because 61 is not less than 4. In fact, 61 is significantly larger than 4, so B4 is false. Now, let's quickly talk about sort of the AND operators and the OR operators. So the AND operator, we have some examples here, and let's quickly go through them. So for the first example, we type that B4 is equal to B1 and B3. Now let's go back and see whether B1 and B3 were true or false. So as we can see, B1 was true and B3 was also true. And since the and function combines two Booleans and only returns true if both of them are true, then we know that B4 must also be true. And if we look at B2 and B4, then we know that but if we look at this, we can see that B2 is false and B4 is also false. And since both B2 and B4 are false, and does not return true, and B5 is false as well. And for the final example, if B6 is equal to B3 and B4, we see that B3 is true and B4 is false. But although B3 is true, because B4 is false and only returns true if both of the Booleans it combines are true, then since one of them is true and one of them is false, B6 ends up being false. And now let's quickly look at or. So the Boolean B7 is equal to B1 or B2. So B1 is true, B2 is false. And since or returns true if at least one of the two Booleans it combines is true, and B1 is true, then B7 is also true. Next, let's look at B8. B8 is equal to B4 or B2. And since both B4 is false and since both B2 is false and B4 is false, then B8 is also false because we need at least one of the two Booleans to be true in order for what it returns to also be true. But since they're both false, then B8 is also false. Next, we have B9 is equal to B1 or B3. And since B1 is true and B3 is also true, and or returns true if at least one of the two Booleans it combines is true, then B9 is also true. And this Boolean down here is just to show you that you can actually combine the operators. So as we can see, B4 we have B10 is equal to B1 and the combination of B4 or B3. So first, let's look at the inside part, which is B4 or B3. Since B4 is false and B3 is true, and the OR operator returns true if at least one of the two Booleans it combines is true, then the combination ends up being true as well. Now, if we look at B1, we see that B1 is true the combination of these two booleans is also true. So now we have true, and since and returns true if both of them are true, and both of them are actually true, B10 is also true, which is the final result. And okay, and now we have a few questions. Okay. Okay, I see someone talking about asking whether B4 is true. Okay, I apologize for this, but I made a mistake in my numbering. I ended up declaring a variable B4 here that is false, and then another variable B4 that is true. And something that you never want to do in Java is declare two variables with the same name. But since I'm very bad with my numbering, I accidentally made both of these B4. So just know that this B4 and this B4 and this B4 are all like representing the B4 from the first line. So like anything that it equals will be taken from a Boolean in the first part. But again, since this is a pretty bad mistake, I will fix this. I will update the handout and resend it in the Google Classroom with all the fixes. Yeah. Let's see. What key on your keyboard would you use to type OR? I mean, this is different for everyone, I think. I'm not sure if this is the same for everyone. For me personally, it is found, so if you go to the right shift on your keyboard and go up one, it should be around there. And yeah, that's where my OR key is located. How does the XOR operator work? The XOR operator is a thing, but we won't be talking about the XOR operator because even I've done competitive programming for like 4 or 5 years, and I can say that I have never once used the XOR operator, so we won't be discussing it because it is not useful in competitive programming. Well, I mean, it could have its uses eventually, but most of the time it's not really necessary in my opinion. And can or combine more than two Booleans? I mean, no. And or can only combine, they must combine exactly two Booleans. Now, if we used multiple ors, we could combine multiple Booleans, but when we're only using one or like this, then it can only combine two Booleans. All right. Next, let's talk about characters. So characters are exactly one keyboard character, exactly as the name implies. So, one, Y, hashtag, all of these would be, Java characters. So nice. So chars are characters or chars are generally declared with single quotes around the character. So as you can see, when we declare chars, they generally have single quotes around them. All chars can actually be converted into integers by their ASCII value, which is also sometimes helpful. And I've also included an example here. And as you can see, there isn't really much about chars that I believe is useful in the USACO Bronze level, which is why there isn't much background on them, but it's still worth knowing what they are. So as you can see, we can declare a char C1 as A. This is how we declare it. This is how we declare char C2 as B. And we can actually convert from chars to integers, as shown here. And since A has an ASCII value of 97, then temp would equal 97 in this circumstance. All right. Now, let's move on to the last data type that we are going to talk about, which is strings. So, whereas a character is just one keyboard character, a string is like multiple characters put together. So you can think of them as English words or just sets of characters combined together. So yeah. And I will note that strings can actually be quite useful in USACO Bronze. I remember a few questions. I don't remember exactly from what years, but there are a few questions where like you have to be good at string manipulation in order to solve them. So yeah, strings are pretty important. But anyways, let's get on to their properties. So strings are generally declared with double quotes around the string, as shown here, and here, and here, and here. To combine strings, we use the plus operator. So as you can see, for S5, we can combine S2, S3, S3, and S4 to make rich is cool. And so as you can see, like S2 is rich, S3 is S3 is again, and S4 is cool. So this will just make is rich is cool, which is a true statement, by the way. I think rich is very cool. But anyways, strings cannot be compared directly with s1 equals s2. Instead, we use the statement dot equals s1 s2. So as you can see here, strings s6, which is rich, and string s2, which is also rich, are clearly the same because their messages are both rich. So if we want to compare whether the two strings are equal, instead of using equals equals, which we normally do, we would do s2 dot equals s6 to check if they both have the same string. And in this case, OK would be true because rich and rich are the same. And to finish off, let's talk about a few important string commands that are extremely helpful in solving problems. The first one I want to talk about is .charat, which returns the specific character at position I. So here, char test equals s5.charat5. If we look at s5, it's rich is cool. And if we go to position 5, then we can see that the character at position 5 is I, it's actually in particular, it's this I, the first I at the beginning of is. So test would equal I. Next, if we look at index of returns the index of the first occurrence of a given string s. So looking here, first post equals the index of is in the string s5. Again, if we look at the string s5, which is rich is cool, the first time that is shows up is at position 5, or starting right here, which is why first pose will take on the value of 5. Another important method is substring position 1, position 2, which returns a part of the string from position p1 to position p2 minus 1. And you might be wondering, well, why p1 to p2 minus 1 and not p1 to p2? Well, I don't know. You can ask the people who made Java why they decided to make our lives harder. But anyways, so if we had string s7 equals s5.substring 5, 10, then s7 would equal is, because we start at position 5, which is the first I, and then we end at position 10, which is the first space. So as a result, the substring would just be is. And the last important function that we are going to talk about is the .length function, which returns the length of the string. Pretty self-explanatory. If we let the length be the length of the string s5, because s5 is exactly 16 characters long, then the length would have a value of 16. Pretty simple, I think. Now, strings can be a bit complicated, especially because there's so many methods and stuff to remember. So if anyone has any questions, then feel free to ask them right now. Oh wait, yeah. Okay, someone said in the chat, wouldn't string s5 be rich is cool without spaces? And okay, yeah, sorry, that was my bad again. I accidentally forgot to put spaces after the s2 and s3. But again, I will fix that in the updated version of the handout. So yeah. Does anyone else have any other questions? All right, if not, let's move on to the next section in which we talk about data structures. And in particular, we will go over arrays and array lists. So the two most important types of data structures that we deal with in Java are arrays and array lists. And these are important because they allow us to sort of hold multiple pieces of data at the same time. So while a single integer like int x equals 1 can only hold a single integer at a time, arrays allow us to hold multiple integers, which is why they're extremely important. So let's start off by talking about arrays. So arrays are one of the ways we can store multiple elements. And the main downside, or upside, I guess you could say, and the main thing that separates them from array lists is that the size of an array is limited by its declaration. And what this means is when we create an array, so as you can see, this is the syntax for creating an array, int array1 equals new int 3, we can see that we have this 3 here. And what this means is that array1 must always have a size of 3. It cannot change. So for example, if we already have 3 elements in the array and we try to add a 4th, that would not work because the array's size is static. It cannot change. Another thing about arrays is that we can retrieve stored elements. For example, if our array is this, then we can access any of those elements later on. So as you can see, we can here, actually, I guess I'll go over this real quick, but we can change the values in the array like this by just saying array1, the 0th position in array1 is now equal to 1. We set it equal to 1 here. The first position of array1 is equal to 2. We set it equal to 2 here. And the second position of array1 is equal to 3, which we set equal here. And something to note is that we can actually change the values at the positions. So even after we change them for the first time, we can change them again. So array1, 2 equals -3. We can change the value at the second position from 3 to -3. And once we've done that, we can see that our array that after this will be 1 to -3, and it is possible to retrieve values from an array like this. All right. The next thing we will talk about is array name.length. And array name.length gives us the number of positions that our array can hold, or it just gives us the size of the array. So as we can see here we do the size equals array2.length. And this just means that, this basically just means that we want to assign the size of array2 to the size, or this variable here. And if we go back, we can see that the size of array2 is just whatever number is in this box. And since yes is equal to 20, as declared up here, then the size will equal 20 because that is the size of array2. And the last thing I want to talk about, which is another important function in Java, is how to sort arrays. And this is done with the arrays.sort command. And this just puts all of the elements of an array in order. So for example, if we sorted array1, then since array1 originally had the elements in the order 1 to -3, after sorting, the elements would then be in the order -3, 1, 2, because -3 is less than 1 is less than 2. And as always, does anyone have any questions about this part? Is it possible to have an array with multiple data types? Oh, this is an interesting question. And the answer to this is yes, you can have an array with multiple data types. Is this going to happen in USACO or the USACO competition? Almost definitely not. I have never seen this pop up, although it is cool to know that you can do this. If you're wondering specifically how you might go about creating an array with multiple data types, you could do this by creating an array of objects and then assigning an individual object to each one. And yeah, it's a bit complicated, but although it is possible, just know that it probably won't show up in USACO. So, yeah. And again, I do understand that I'm going through a lot of the basic Java stuff kind of fast, because today is sort of supposed to just be a quick review of Java syntax so that we can really get on to like all the problem solving inside USACO in the next 3 classes. So again, if you're finding some of this hard to understand, then I strongly encourage you to go to the link in the handout above and quickly have a more in-depth explanation of how all the Java syntax works in Dan's class, which I did link above, I believe. So yeah. Why does array length not need parentheses at the end? When I first started, I just knew that like basically it's just a thing that the Java people do to kind of annoy us, I guess. Like it is kind of annoying because whenever we're trying to get the size of like certain things, like the length of string, the length of array list, the length of arrays, we have to use different declarations for all of them, which is a bit frustrating. And you pretty much just have to remember which ones go to where. The actual reason as to why this is because some of these are properties, whereas others are characteristics, and others are like parts of the class. And it's a kind of complicated explanation. And since we're running a bit low on time, for now, just know that this is something that you'll generally just have to memorize. And yeah, again, I apologize that the Java syntax writers did not make it easier for us to remember. And they made it like different for every single data structure, which again, I'm kind of annoyed by, but whatever. All right. So next, let's talk about the second data structure, which is arraylists. Arraylists are another way that we can store multiple elements in Java. And the main difference from arrays, as we mentioned before, is that we don't know the number of elements that must be stored in an array list, as they do not have a fixed size. So let's quickly talk about some of the main things that array lists cover. The first thing to note is that whenever using ArrayLists, we have to write the line import java.util.star at the top of our code to be able to use ArrayLists. And the reason for this is just that the Arraylist class is not part of the OG Java stuff. You have to import it from a package. And unlike with arrays, the size can change after its declaration. And as you can see, the declaration of an ArrayList can be found here. So here's an ArrayList of integers, and here is a ArrayList of characters. And yeah. ArrayList can also retrieve stored elements. So if our ArrayList is 1 to 51, we can also access any of these elements later on, similar to arrays. And now let's quickly talk about some of the commands. So the .add command allows us to add new elements to the end of our ArrayList. So here, if we do list1.add1, list2.add51, and list2.add2, then this just continuously adds elements to the end of our ArrayList. So after the final add command, our ArrayList would equal 1, 51, 2. And here we can also add characters. So at the end of these two commands, list2 would equal A, B. The next command we'll talk about is the remove command, which allows us to remove an element at a certain position from our ArrayList. So as you can see, actually, I guess we'll talk about set as well, because this is important. But the list2.set command allows us to change the value at a certain position on our ArrayList. So as you can see, we start out with the ArrayList AB, but after we set the value at position 0 to C, then A, since A is currently at position 0, it gets changed to C. So after running this command, our list2 will equal C comma B, because A got changed to C. And the remove command just removes the element at a certain position. And since B is the element that is currently at position 1, after writing list2.remove1, our command will equal C, because we've removed the element at position 1. The next three commands that we'll talk about are the .get, .contains, and .size functions. So the .get is basically just our way of obtaining the value that, basically it just tells us where currently is this, what element is currently at position X. And that's what this command allows us to do. .contains, again, just pretty much does exactly what its name implies it would do. It tells us if the ArrayList contains a certain value X. And unfortunately, .size tells us what the current size of our ArrayList is. And yeah, you're going to have to memorize the different .length, when to use .length and when to use .size, which is a bit unfortunate, but yeah. So as quick examples, we can see that when we do char temp equals list.get1, because list2 currently is k comma c, we can see that upon doing this, temper will equal c, because this is our current ArrayList. So temper will equal what is currently at position 1, which is C. When using list2.contains, let's see here, we have Boolean has equals list2.contains A. And since our ArrayList is k comma C, and it does not have an A in it, then has will be false, because our ArrayList literally does not have A in it. And lastly, if we say int bigness equals list1.size, then since list1 currently has 3 elements in it, 1, 2, and 51, then bigness will equal 3. And the last thing I want to point out that is sometimes useful is collections.sort, which allows us to sort the elements in our ArrayList. So here in collections.sort, we can see that although we start with the elements 1, 52, 2, after sorting, since 1 is less than 2 is less than 51, our ArrayList will become 1, 2, 51. So that's another important function that is sometimes used. What if we use a number out of range for any of these? Oh, that's a good question. I'm gonna be honest, this is an error that I run into too many times where I don't keep track of how big my array is. But so whenever you try to access an element that is out of bounds, you're basically just gonna get an error, your Java program will crash, and you're going to have to spend a while figuring out what made it crash. So yeah, if you try to use a number out of range, then you're going to get an error. Are there any other questions? All right, if not, then I'll quickly go over to the arrays and ArrayLists as well. So for example, if we look at this right here, this is an example of a one-dimensional ArrayList or array. But sometimes we're going to have to create 2D arrays or ArrayLists because these allow us to be more efficient with storing information. And since these aren't super important, like they are used very occasionally in USACO Bronze, but since again we're running short on time, and I don't think they're like super important for everyone to know yet, we won't go too far in depth into them. But just know that you can actually create a two-dimensional integer array, such as the one shown below. And yeah. Now let's move on to input and output. So input, or when we're reading information, is something important, especially in USACO information, especially in USACO competitions, because how an USACO competition works is that they're going to give us some amount of information, and then we're going to have to output a number based on that information. So like they might tell us like, hey, you need to average the three numbers I give you. And they might give us the numbers 1, 2, 3. And well, if we can't read in those numbers, then how are we going to ever answer the question, right? So yeah, let's quickly learn how to input numbers. So the first thing we need to do is to type the line import java.io.star at the top of our Java program, because this will allow us to use all of the input-output functions. Next, we will type the line scanner in equals new scanner, new file, name.in. And the only thing you need to know about this is that we need to replace this name with whatever we need to replace the word name.in with whatever our file is called. So if our file is called like coolman.123, then we will replace name.in with coolman.123 so we can read in from that file. And in general, the setup is described here. We have import java.util.io, import java.io, and this is the import line. And then here we have our scanner declared with, for example, and this is if we're reading in from the file cake.in. And note that it's also important that we write throws file not found exception, because this is just another thing that we have to watch out for. And yeah, this is just sort of the setup for how to read in information. So now let's quickly talk about some of the important commands that we can use when reading in the information. And honestly, I think that these commands are like really self-explanatory. I mean, like literally, it just says next line, next Boolean. Like, I really wonder what these could represent, right? It's almost as if they are self-containing names. But we'll also give a quick example in case some of these are just a bit confusing. So if our file cake.in was I am cool, cows, true, 8, and 3.0, then if we wanted to read this file into Java, we could do the following. So we could first let string data1 equals in.nextLine. Then we could say data2 equals in.next. Boolean data3 equals the next Boolean. Int data4 equals the next int. Double data5 equals the next double. And the important thing to note here is that whenever we want to read in a double, we want to use in.nextDouble. Whenever we want to read in an integer, we read in in.nextInt. And whenever we want to read in a string, we either use in.nextLine or in.next, depending on how long the string is. And yeah, I see a quick question. Someone asks, are Booleans true or false? And Booleans can be true or false depending on how you define them. For example, if we set a Boolean equal to 1 plus 1 equals 2, then that Boolean would obviously be true because 1 plus 1 equals 2. But if we set a Boolean equals to 1 plus 1 equals 3, then that Boolean would be false because 1 plus 1 is not equal to 3. What is the difference between .next and .nextLine? This is a good question. .next is used. Okay, so .nextLine just reads the entire next line of the file. So I am cool. We would use .nextLine if we wanted to store this entire string because there are spaces in it. However, if we wanted to individually store I and then am and then cool in individual strings, we would use .next because .next stops whenever it sees a space. So that's the main difference. If a Boolean is true, does it equal 1? Yes, this is something else. Booleans are 0 when they're false and 1 when they are true. Does it include the space? No, it does not. How much time do we have left? We have like 8 minutes. So there is a chance that we will not be able to get through everything. And in that case, then I will probably just leave you all to read the rest of the handout on your own. So yeah, again, if anyone has not joined the Google Classroom yet, the entire handout can be found at this link. And the handouts will also be posted on the Kid Teach Kid website at some point, but that part of the website has not been finished building yet. So for now, you can just use the Google Classroom to get into the handouts. And all right, next, let's talk about, let's quickly discuss output. So now that we've learned how to input information that the program gives us, we also have to know how to like give something else. Like, because for example, during the USACO competition, their system is going to give us some numbers, and we can read those in, right? And we can get an answer. But if we can't even tell their checker what our answer is, then how are they going to judge if our code is correct or wrong, you know? And luckily, printing out information is much simpler than all the stuff we have to do for inputting information. The only two commands we have to know are system.out.print and system.out.println. And the only difference is that the second one prints out a new line after it prints out something. And this is pretty simple. I won't go too far in depth into this because I think it's pretty self-explanatory. But for example, this would print out this. And yeah, okay, we are running very short on time, so I will just quickly skip to the next section because I do not think this is too difficult. And if you have any questions, then you can always just email support@kidteachkid.org, or you can go back to the handout and read it later. All right, now let's talk about conditional statements. Whew, all right, so what are conditionals? Well, conditionals work exactly as the name suggests. In programming, there are lots of times like when we only want to do something when a specific condition is met. And we use if-else statements to sort of get around this. And the if-else statement, I think, is really self-motivating, or it's really, I think that the if-else statement is really easy to understand because all that is that, well, if condition 1 is met, then we do whatever's in this part of the code. If condition 2 is met, we do whatever's in this part of the code. If condition 3 is met, we do whatever's in this part of the code. And then if none of the conditions are met, we do what's in the else part of the code. So, and yeah, I think that this is best understood with examples. So I will quickly go on to some examples here. So as an example, if we wanted to print out 0 if a number is less than 8, 1 if it is equal to 8, and 2 if it is greater than 8, then what we could do is we could read in a number from the file, then say if x is less than 8, we print out system.out.println 0. If x is equal to 8, we print out system.out.println 1, and if it's neither, then it must be greater than 8, so we can print out 2. I'll quickly just go over the second example as well. If a number is divisible by both 3 and 4, then we want to print out high. So again, we read in x from the scanner, which is done here. And if x is divisible by 3, which is represented by the first part, and x is also divisible by 4, which is represented by the second part, then we print out high, which is represented by this conditional statement. And I won't go over the third example because we are running low on time. I do see a question, which is how can you get 0, 1 or 0 with the Booleans? I'm not exactly certain. I know in one of Java and C++, you can automatically just say like int equals false. But a surefire way to do it is to just say like, let's say that x is our Boolean. We can just say if x is equal to true, then print out 1. And if x equals false, then we can print out 0. So that's how we can convert Booleans to integers. I hope that answered the question. I'm not sure if that was what you were asking. Okay, and I have like basically no time to cover these loops, so I'll try my best to cover these in like 1 minute. Okay, yeah. We'll try our best, okay? But okay, so these are loops, okay? And loops are just used to do something multiple times because it's really inefficient for us to have to type the same thing over and over again. Like if we wanted to print out high 1,000 times, the last thing we want to be doing is to have 1,000 lines all with system.out.println high. Like that's just completely inefficient. So as a result, we have loops, and loops are here to be extremely helpful so that we can do things multiple times without having to write 1,000 lines of the exact same line. So the easiest Java loop to use is for loops, and the other type is while loops. So how for loops work is that there are 3 parts, right? So this is the loop, and inside here we do stuff. So how this works is that the outside part, or this line, just sort of tells us how many times we're going to be doing the stuff that's inside here. The way we can determine this is that the first line tells us I equals 0, the second line tells us I less than 10, and the third line tells us to increase by 1 every time we do the loop. And since we start at 0, and every time we run the loop, we increase it by 1. So for example, after the first iteration, I will increase by 1 and become 1. After the second iteration, it will increase by 1 again and become 2. And it'll keep doing this until I is no longer less than 10. Then the loop will stop. So as a result, this loop will run 10 times. And I won't go over while loops because we have no time. But okay, yeah. I know that I rushed through the ending part. I know that especially the ending part, I rushed through quite a lot. So if you want to go back to the handout and review it by yourself, then feel free to do so after the class. But yeah. And since we have 2 minutes left, I would like to be able to answer any final questions that anyone may have. Oh, and if you have any questions about the handout or anything like that, then you can email support@kidteachkid.org, and we will get back to you as soon as possible with a response. So yeah. And yeah, I do know that this specific week was a bit special because I just sort of wanted to review exactly like what all the Java functions are, like how the Java syntax works. So in the upcoming weeks, we will, instead of focusing on like what these specific data structures and data types are in Java, we'll be focusing a lot more on solving USACO problems and sort of like the theory behind coding, stuff like that, so that we can like sort of train our problem solving minds as compared to, going over Java syntax like we did today. So if you already knew everything that was covered in the handout today, then don't worry, because we will be covering actual USACO coding, or like we will be covering actual USACO problem solving in the upcoming weeks. And since it is 4 o'clock, I believe my time is up, and I will hand it over to Andy. And Andy will be going over USACO silver problems, and you should definitely stay for his course if you're interested in learning from the master coder. So yeah.
Rich is a great coder too. Just saying. Thanks, Rich.
Okay, so wait, how do I stop sharing my? Oh, and also thanks so much for everyone for attending the USACO Bronze class. Yeah, okay, bye.